Welcome everyone. Sorry. Yeah, good. I'm Liviu. This is my colleague John. We're going to be delivering a fairly technical presentation on Symfony I, Dependency Injection Symfony I, not Symfony I, Magento I, but also hopefully how we can use some of these lessons and practices to have an easier time migrating to Magento II, as obviously Magento II is more relevant now than Magento I. So we've been developing some fairly interesting techniques of adopting a TDD approach on our Magento projects over the last 12 months. And this is an attempt of condensing all of our lessons and all of our learnings over the last 12 months into about 25 minutes. So yeah, I hope we can do that. So just to give a quick brief presentation about who we are. I'm Liviu, technical team lead at Inviqa. And
yeah, I've got a microphone, I think. So I'm John. I do training and some software engineering at Inviqa. I've worked a little bit on Magento, and I've worked together with Liviu developing this module, which, as you'll see, helps make Magento I a lot more easy to test.
Cool. Okay, so yeah, let's get to it. So the plan for today is to talk a little bit about inversion of control. Mm-hmm. John, can you tell us anything about that?
Well, we'll get more into that in a moment, but just suffice to say, inversion of control is a way of getting your classes to be provided with its dependencies instead of it having to ask for dependencies.
Cool. Then we're going to talk about what kind of options do we have in Magento I for managing dependencies. What is one of the better options of injecting your dependencies? How do we define services and how do you configure your services? We're going to show you how to do it from a practical perspective. We have lots of code examples, and we've also put together a GitHub repository with all of these code examples if you want to play with them. And in the end, highly unlikely, but if we have time, we're probably going to do a quick demo. If not, we're at least going to show you some cool things about dependency injection in Magento I on an actual live project using PHP Storm. So, quick disclaimer, this talk is quite technical, so if you're not a developer, I apologize. Probably a lot of these things are not going to make sense to you, but if you're a developer and if you care about TDD and dependency injection and Magento, then this is going to be quite relevant for you. Okay,
I was going to say
that. John, continue?
Apart from that, if you care about making more testable software with Magento, then you should be caring about this. So a little bit about inversion of control. So ordinarily, at least in Magento I, in Magento II, this is something you already have. Ordinarily, we would get each class to ask for its dependencies explicitly. You know, the normal Magento way is to use get model, get singleton, and ask for the dependency that your class has. And if we want to effectively have dependency injection, which is what we really need in order to make our classes properly testable, then we need some kind of mechanism by which the dependencies are provided to the class. Inversion of control is the most common way of achieving this.
So why is this so important? Can anyone tell us why should we care about inverting our dependencies and not just explicitly depending on global state throughout the code base?
It makes, yeah, it helps you to achieve dependency injection, which, like I said, is something you need in order to make your code more testable. And we'll see how we can do that in a moment.
How does this tie in with TDD techniques and with decoupling and building more modular code?
Well, with TDD, we normally want to test classes, units in isolation. And as most of you know, in Magento I, this is almost impossible to achieve because it relies on global state and it relies on hard coding dependencies into the classes themselves. Inversion of control is implemented using something called a dependency injection container, which is something that exists in Magento II, like I said, but not in Magento I. So we've taken Symfony's DI container, we've written a bridge so that it could be plugged in as a Magento extension into Magento I. And there you have a DI container out of the box with Magento I, making your code imminently more testable.
Can we see some examples of maybe a very simple model that depends on some global state, and then let's see where we want to get in terms of decoupling our dependencies?
Yeah, so let's see how we had to handle code before having inversion of control or a DI container. So I'm sure you're all familiar with the way of Magento's way of constructing new instances of classes. You use the mage global get model method. As you can see, this example class here, which is a currency converter, has two dependencies. One is a foreign exchange dependency, so that it can do the get the foreign exchange rate, and the other one is a currency formatter, so that you can format into various currencies. But these dependencies are hard-coded. It's not easy. It's in fact impossible, the way it's written at the moment, to swap them out in order to test this currency converter in isolation. So what can we do about this?
Cool. Just one thing to notice here, obviously not everyone uses constructors in their models. This is if you care about grouping your dependencies into one place, but either way, this can be improved. So if we move on to the next example, is this any better, John? What do you think?
Well, here, this is slightly better, because now we've removed the hard-coded dependencies from the currency converter, as you've seen, and we're using what's known as dependency injection to inject our dependencies into the currency converter constructor. The problem is this still doesn't give us testability, because the actual dependencies themselves, the foreign exchange rate, the currency formatter, still hard-coded, but we potentially have a class, the currency converter, which has dependencies that can be injected, and in some way we want to be able to test it in isolation from the rest of the system. We want to be able to swap these out.
So, I'm not sure if it's obvious to everyone here. This example is fairly simple. We just have one basic controller with an index action, which depends on the model with the dependencies. But as John said, if those two dependencies have a complicated tree of additional dependencies, you can imagine how the controller would get very, very complicated. So you're removing the problem from the model level, so you can unit test the models, but then it becomes very, very messy when you have to write all this down in your controller.
Yeah,
so
for example, the foreign exchange might have its own dependencies.
Exactly.
And those dependencies might have their own dependencies, so you can imagine how complex a constructor could get if you're using dependency injection, but you don't have a DI container to manage it.
But you still get something out of it. So even with this approach, which I admit is a little bit unusual in the Magento world, you are able to do some unit testing with your models. It's just that you have to keep in mind that putting everything together in your controllers, observer, block classes becomes a nightmare really quickly.
So how we can improve this?
Exactly.
Didn't we skip something?
No, these are the only two slides here.
Yep.
So the next section we're going to talk about is dependency management without a container, which is just what we saw earlier. We're going to have a brief overview of Magento factories and how object instantiation in general is managed in Magento. We're not going to go too deep into this. We're just going to talk a little bit about get model, and again, why is it hard to test your classes if you use get model everywhere. And we're also going to consider some options that might not be the best options, but we're just going to explore as many alternatives as we can before we delve into the dependency injection container library. So the plan is to present as many options and then present the final outcome. So yeah, John, do you want to continue from here?
So
this is very similar to what we had before.
So what we have here is we still have the dependencies hard-coded in the constructor. This is what the currency converter logic would look like. Like I said, we have two dependencies, foreign exchange, which has a method to get the GBP to USD conversion rate. And we have a currency formatter, which formats into a readable format for dollars, for example, adding a USD or dollar symbol. These are how the two dependencies in the class are used. The question is, how do we swap them out for the purpose of just testing this class in isolation from the rest of the system?
So yeah, in this case, the problem is partially solved for the controller, because the controller will still do something like Magento model, whatever the model is, and we're just trying to partially also solve the problem for the actual models. And this is one alternative. Probably not a lot of people use this alternative, but it's something we started with on one of our projects before we ended up looking at the Symfony Dependency Injection container. So this code is very verbose. You can see in the constructor that we receive an array of parameters, and we're just taking advantage of the fact that Magento allows us to pass an array of parameters in our models constructors. And if there's something set in that array, then we're going to accept that as our dependency. If not, we're going to revert to Magento model. And the only benefit this has is that if we use something like PHP unit or PHP spec for driving our tests, we now gain the ability of injecting testables into our class.
So now the class is testable in isolation.
So how would that test look like?
Well, we'll look shortly at the test in a moment, but there's still a problem that we need to mention here, in that if foreign exchange has dependencies and currency formatter has dependencies, then it becomes incredibly complex to manage all those and juggle them together. So at this point, without a DI container, we can't really continue to look at testability in Magento. So, okay, this is another example of providing. This is okay. Do you want to talk about the test
so if you're
itself?
using PHP spec,
how a test would look?
Yeah, if you're using PHP spec to drive your unit test, then this is how you would send your testables, which in this case is the foreign exchange and the currency formatter to the constructor of the class that is under test. If you're using something like PHP unit, it would be very similar, but not quite the same.
So just to be clear, the foreign exchange and currency formatter here, the two dependencies of the class, for the purposes of the test, it's using stand-ins, doubles, and we're hard coding what those services will return for each case.
Cool. So you have a way of unit testing your code this way, without then using any fancy container or anything like that, but it's not ideal, and it requires a lot of verbose code, both in your constructors and also in your unit tests. Like you shouldn't be needing to specify an array of parameters to pass in your constructor like this. You can do that. We can improve on this, and we can do this better.
And as we said, if those dependencies have dependencies, then you have a problem still. You will still not be unit testing the class in isolation.
Cool. So finally, we've reached the fun part. So this is where we are going to introduce the Dependency Injection Container library. Basically, this is a module that builds on top of the Symfony 2 or Symfony 3 Dependency Injection Container. And it leverages the same way of dealing with dependencies into Magento. So this will allow you to specify your dependencies similarly to how you do it in a Symfony application. The library itself is a very thin Magento 1 layer. Unfortunately, Magento 1 doesn't really have a proper way of dealing with dependencies. You don't have to do this in Magento 2. Magento 2 has its own way of dealing with dependency injection, but I'm sure lots of you are still working on Magento 1 projects. So if you are able to inject your dependencies in Magento 1 projects, then your code and your classes are easier to migrate to Magento 2. So we're going to talk a bit about the library itself, and we're going to show you and talk about how everything is wired together using XML configuration. So after you define all of your dependencies in your models, you have to tell something which service is connected with which other service, and you do that using XML configuration. And in the end, depending on how much time we have available, we're going to talk about some very interesting edge cases. Let's say if you're building something that connects to a third-party API, and you don't really want that third-party code to be running when you are executing your integration tests or when you are doing your CI, then there is a way to go around that, and we'll go into more detail in just a few moments.
Just to recap what Liviu said as well about the DI container library. If you have Magento 1 project and you are looking to migrate to Magento 2, This is a way of doing it gradually, because what the DI container allows you to do is completely decouple your code from the Magento framework, and then in theory your classes work wherever they are. You can just move them from one framework to another framework. Logically they work exactly the same.
Cool. So how do we do that? Let's have a quick recap of what we have before, and also where we want to get. So this is the ideal point. This is where we want to get. We want to create classes, Magento modules, that get their dependencies passed into their constructors, and we want to obviously make sure that we can use any sort of PHP, unit testing library, and also we want to make sure that this doesn't add additional overhead into our controllers, observers, or block classes. So this is where we want to go, and the question is, how do we get to this point?
So as you can see, also the class is not requesting any dependencies here.
Yeah.
There's nowhere you can see that the class is asking to use a foreign exchange dependency or a currency formatter. The control is given to the DI container, hence
Exactly.
the inversion of control.
So this also allows us to develop our code in a TDD fashion. We define our tests first, then we implement our class based on those tests, and then we worry later about how everything is hooked together in Magento. So yeah, this is just another example of PHP spec. If you guys are like using PHP spec for unit tests, we don't have to deal with that messy params array. We just pass the doubles, which is foreign exchange, and the formatter directly into the constructor of our class here.
So it's an example of how a unit test for that class might look.
Yep. Cool. So this is the library. It's called Inviqa Magento Symfony Container. You can get it on GitHub, and you can obviously use Composer to install it. You just need to type composer require Inviqa Magento Symfony Container, and this is going to create a module inside your vendor folder, but is also going to automatically symlink that module inside your community Inviqa folder.
So this this relies on a plugin that was written called Magento Composer Installer,
Exactly.
which allows you to use Composer with Magento and install Magento modules using Composer.
Cool. But that module is already a dependency of the Magento Symfony container. Okay, so we've defined our model, which is the currency converter.
How do we wire up with these dependencies?
We've written our unit tests, our class has been implemented, and now we just need to hook everything together. So after we've installed our module, we have to create our services XML file. This is the service configuration file in our module. As you can see, this module is called Inviqa demo, and the configuration file goes into the etc folder. We have our two dependencies here, which is the foreign exchange. So we have to define a service which has an ID of foreign exchange and the class of that service. And it's exactly the same XML language that you'd be using in a Symfony application. We also define our second collaborator or dependency, which is a currency formatter. And then we say that our converter receives those two arguments, which is the foreign exchange and the currency formatter. So basically, this is going to create a dependency tree, and the container itself is going to know that our class is going to get its dependencies injected.
Exactly. So when your controller asks to use the Inviqa demo currency converter service, it's going to look at this configuration and know, I need to instantiate this with two other services, which are defined as those classes. Those classes could have their own dependencies ad infinitum.
Cool. Okay, so let's have a quick look at the controller. This is very, very simple. We have our demo index controller again. Here, I guess on line 4, we are using the service provider trait. This one, we don't have to use this. This is just an example. There are multiple ways of fetching the Symfony container itself.
This is the most convenient.
Yeah, and this trait exposes just one method, which is called getService. And this allows us to fetch any service from the container. So in this case, we want our controller to use the currency converter. So inside the controller, we just ask the container to give us that service, and then we can call methods on the service. So this replaces MageGet model Inviqa demo currency converter. We just have to do this getService Inviqa demo currency converter.
But as opposed to MageGet model, it causes the DI container to instantiate the dependencies and the dependencies and so on.
Right, but John, this doesn't look like dependency injection to me. It kind of looks like a service locator. What's the deal with that?
Okay, that's true. So a service locator is like a simple DI container. It just contains a list of services. And if those services have dependencies, it doesn't know how to deal with those dependencies. You just ask for the service by name.
But
so using it in the controller, it really does look like a service locator.
Why aren't we injecting the dependencies in the controller like the way we use in the models?
In Magento I, we have no control over how we can instantiate the controller or the block or the observer. So in these high-level classes, we have little option but to request for the service explicitly.
So obviously we have to deal with this painful reality that we cannot define controllers as services like we do with Symfony applications. And from personal experience, the best way to deal with this is to keep your controllers as small as possible and as slim as possible, and also reduce the number of dependencies in your controllers. So even if you have a very complex application, and normally you'd have, let's say, 20 dependencies in your controllers, it's better to abstract away all of those 20 dependencies into another model, then call that model from the service locator inside the controller, and then use proper dependency injection for all the other collaborators and all the other services.
So let's have a look at how that works.
Yeah. Ooh, this is
okay. There's another problem.
It's another problem. So before we go to that, let's talk about a very serious challenge that you're going to have to face once you start
doing integration testing.
Yeah, exactly. Do you want to present this, John?
Yeah. Okay. So if you're doing full end-to-end integration testing, which you would want to do if it was a commercial application, using either PHP unit or something like Bhat or a high-level integration testing tool, you would normally, and your Exchange service has to talk to a remote API, you would normally want to be able to short-circuit this communication so it doesn't have to actually connect to the remote API.
Give us an example.
And we can stub it to return a specific value that we would like to test it with. We want to have control over that. So this is
an example of what John was talking about. We have this foreign exchange dependency, which has some crazy curve logic inside it that tries to send something to Google to fetch some sort of foreign exchange rate. And if we put together an integration test, let's say we use Bhat, use PHP unit, or any other framework, then this is going to cause us problems because we don't really want to talk with real APIs during our integration tests, and specifically when running continuous integration. So the best way to go around it is to try to come up with a way to create a replacement for your service. So in this case, the service is called Inviqa demo foreign exchange. If we could have some sort of fake foreign exchange that doesn't do anything, but maybe just returns a static value, let's say 1.2, and if we can figure out some sort of way of magically replacing our Google foreign exchange with our fake one, just on our development environment and just when we're doing integration tests, then that will help immensely in actually being able to achieve these integration tests. So
exactly.
This is an example of the foreign exchange that depends on a curl connection to Google. And in the next slide, we can see an example of something much simpler, which is just a fake foreign exchange that doesn't do anything. It just returns a static value. And obviously, we have to figure out how to go from that to this.
We need some sort of way so that when the integration tests are running, this Google foreign exchange service is swapped out with a fake foreign exchange service with a value that we know in advance. We don't need to rely, the test doesn't need to rely on connecting to third-party API services, and it will be a lot more stable.
So how is it possible? How can the container library actually achieve this?
Okay, so we need to tell Magento somehow in its configuration that it will load a different version of this service, perhaps through a test file. And as we can see, we've built in a way to tell Magento using an environment configuration that we wish to run the system in test mode.
Exactly. So all you have to do is define the test environment variable, and that's it. The container is going to automatically swap your services with fake ones. I think one thing that we might have forgot to mention here is that in the original service definition, we have this service ID, which is Inviqa demo foreign exchange, and this sits under services XML. However, for the fake implementation, we create a similar service configuration and we put that in a different file called services_test.xml. And this has the same service ID, but obviously the new class, which is fake foreign exchange. So by specifying the test environment variable, we are telling the container library that it should load up the services test.xml configuration files, and it should replace everything it finds there with all the other real services. And
nevertheless, it's up to you in your continuous integration environment to figure out a way to add this test environment configuration variable for the duration of running the test.
There are other even better ways of defining your test services. We're not going to go too deep into that because we're running out of time. Just as one simple way of doing it. Obviously, if you're interested in finding more ways about how to implement test services, more than happy to help. If you want to ask us directly after this, or if you want to check the public documentation on the repository. So this is amazing. I mean, what did we have to do to reach this place? What did we have to do to be able to write our code in a more testable way?
Well, all we needed to do was run composer require Magento Symfony container and read the documentation and wire up our services together in a way that it's much easier to adopt test-driven development and to unit test classes in isolation.
Cool. So
as we've seen, it's also easier to migrate to Magento II once you've decoupled your classes.
Absolutely. So with just a few minutes worth of effort, it can be a lot easier for us to adopt a TDD approach to our code development. If our code is more modular and doesn't depend on global state, then it's going to be a lot easier to migrate it to other frameworks and other projects. Magento 2 is just one example. You could write code that can be compatible with other frameworks as well. It's a lot easier to obey the single responsibility principle just because you are adopting a TDD approach and you are thinking about how your classes communicate with other classes right from the beginning. Your dependencies are more explicit. You have this services XML file created in this module, and this allows any other developer to see at a glance everything that you depend on, and eventually you end up having, your code ends up benefiting from better design. And once you do this often enough, you will end up writing more and more framework agnostic code, which will eventually help you with your transition to Magento 2.
Yeah, so can we see a demo of all this working together?
We probably can, but I think we're running out of time. We've utilized our half an hour slot. So if you guys have any questions, we're happy to take a few questions. Otherwise, we can talk after this in private. You can approach us directly.
Yeah, just to reiterate how critical this is for testability. And we know how difficult it is to test Magento 1.